What is computational thinking? Computational thinking from self-driving cars, photo apps, flying rockets. Its software technology is founded on fundamental concepts of programming, allows you to take control of the computer and give instructions to do this well. It's helpful to learn how programmers think. This thinking skill is also called computational thinking. Computational thinking helps solve problems. Let's take a look at an example. Emily needs to get to her softball game, but she's running low on fuel and finds the shortest path to the game. What does it mean to do computational thinking? Here are the skill sets. 1. Breaking down a complex problem to smaller solvable units. 2. Recognizing patterns and finding underlying principles. 3. Creating algorithms to solve problems. These are some of the computational thinking skills that a good programmer has. Elements of computational thinking. It can be helpful to think about some of the common elements of computational thinking. For example, logical reasoning encourages your students to make predictions and to give explanations whether or not they're working with computers. Decomposition helps students to break big problems down into smaller parts, whether they're working on their own or as part of a team. Generalization gets your students looking for patterns or thinking about similar problems. Algorithms. The key to computational thinking is working systematically. What steps or rules do you have to follow? And abstraction. What's the right level of detail for the problem? What information matters and what's irrelevant, at least for the time being? Games can be a great way to help your pupils to think computationally. Games have objectives. They have rules. They have some way of representing the state of the play. So it's perhaps no surprise that people have been programming computers to play games for a very long time now. What's an algorithm? In computer science, an algorithm is a set of instructions for solving some problems, step by step. Typically, algorithms are executed by computers, but we humans have algorithms as well. For instance, how would you go about counting the number of people in a room? Well, you probably point at each person, one at a time, and count up from 0, 1, 2, 3, 4, and so forth. Well, that's an algorithm. In fact, let's try to express it a bit more formally in pseudocode. English-like syntax that resembles a programming language. Let n equal 0. For each person in the room, set n equals n plus 1. How to interpret this pseudocode? Well, line 1 declares, so to speak, a variable called n and initializes its value to 0. This just means that at the beginning of our algorithm, the thing with which we're counting has a value of 0. After all, before we start counting, we haven't counted anything yet. Calling this variable n is just a convention. I could have called it almost anything. Now, line 2 demarks the start of the loop, a sequence of steps that will repeat some number of times. So, in our example, the step we're taking is counting people in the room. Beneath line 2 is line 3, which describes exactly how we'll go about counting. The indentation implies that it's line 3 that will repeat. So, what the pseudocode is saying is that after starting at 0, for each person in the room, we'll increase n by 1. Now, is this algorithm correct? Whether executed by computers or humans, algorithms are just a set of instructions with which to solve problems. These were just 3. What problem would you solve with an algorithm?